Assalamu alaikum. Okay, students, I will be showing the solutions of the questions beyond that fifth question of the exercise 3A. Yes, yeah. So let's see how to do the sixth question. Now it says a wooden block of weight 20 Newton. Now there is a wooden block whose weight is 20 newtons. Is at rest on a horizontal surface. So this is very important information, that this is at rest. So we must be knowing if it is moving with the uniform acceleration, or if it is at rest. Okay. Now the rest would mean that this is in a state of equilibrium over here. Okay. So it is pulled by a force of 30 Newton acting at 10 degrees above the horizontal. So there is a force of how many? Yeah, 30 newtons over here. Okay, this is acting at an angle of 10 degrees. Okay, and then it says as shown in the diagram, and remains at rest because of a horizontal force F. Now guess where would the force, the frictional force, would be acting? Towards that 30 Newton force or opposite to it? Yeah, you are right. This is opposite to it. Yeah, I know you people are very intelligent, mashallah. Okay, so here is the force F, which is obviously, if there was no force F, then it had to be moving, accelerating towards this side because of this force over here. Okay, now guess which force I haven't mentioned over here, because it says draw the force diagram for this situation. So you see this was the weight given, this was the force given acting at angle of 10 degrees, and we have drawn it ourselves. Obviously this force has to be opposite to the direction in which it can move. Okay, so now guess which force I haven't shown over here. Yes, any guesses? Yeah, no? Oh yeah, you are right. Okay, so yeah, you are always giving the correct answer. I don't want to name you, okay? Otherwise people will say that I'm doing the favoritism thing over here. So here is that R. Remember the R thing. So here is the R. We have seen the situations where, like, there was a block like this. Its weight was 20 newtons. So this was the R over here. This R was absolutely equal to, like in this case, R is exactly 20 newtons, okay? And if you remember, I told you that if there is another force which is like, let's say 10 newtons over here, so then what would be R now? So that would obviously be 10 plus R, that is equal to 20. So now this R would be equal to 10 newtons. And for example, let's say in the same situation there is a force of 20 newtons over here. So what would be R now? Yes, yeah, R is 0, because if you write this as 20 plus R, so this R is going to be 0. Okay? So, and if your force exceeds this 20, so obviously this will be accelerating upwards. Okay, now coming back to this question, again, if I take you back to this question, I have to tell you, add another thing over here in the same example. Now suppose there is this 20 newtons as we have this over here. Okay, now here is the R. Okay, now if there is an inclined force over here, suppose this inclined force is, as we have here, 30 newtons. Okay, so this inclined force, and let's say this is acting at an angle of, let's say, 10 degrees, like we have it here. Now you have to resolve this inclined force. Whenever there is an inclined force, you have to resolve this parallel and perpendicular to the surface on which your, this object, whatever, this block is over here. So you know how to resolve this. If I show this resolved, this is going to be 30 cos 10, and this is going to be 30 sin 10. Now you forget about the horizontal components. Now you just look at these vertical forces acting on this block. There are two vertical forces upward. One is R, the other is 30 sin 10. And the third force, the third vertical force is 20. So since there is no vertical movement, this is stable vertically. So that means you can say that this R plus 30 sin 10 is going to be equal to 20. So that is how you can determine this R in this case. This R plus 30 sine 10, that will be equal to this 20. So that's how you will find this r, that is 20 minus 30 sine 10. Okay? Now coming back to the sixth question over here. Now this is acting vertically downwards. This is the r thing, the normal contact. This is the frictional component. Okay, and this one I need to resolve this. Okay, so this is 30 cos 10. This one is 30 sine 10. Okay, so you see, as I did in this my own example, now we can determine the values of F and R using the equilibrium thing. So horizontally, how many forces you can see acting on this block horizontally? Yes? Yeah, there are two forces. One is F, the other is 30 cos 10. So right away you have F equal to 30 cos 10. You can use your calculators to find this F. Okay? Now coming towards the vertical thing. So for the vertical thing, I can say this R plus 30 sine 10, that is equal to 20. Okay, so that is how you will get this R. You can check your answer, you can use your calculators. Okay, now I'm just leaving a question for you from this question number 6. Now what if instead of pulling this block towards, like, the right side, suppose you were pushing this like this, okay, like this, then what would be the value of R and what would be your F? Okay, and let's ignore this F for a moment. You have to tell me that would this R be more than the R we're finding in this original situation, or that would be less than this value of R. Okay, so that is a question for you. Thank you.